Hello everyone, welcome to TAF, the Academic Fringe Festival. I'm Jie again, Assistant Professor in the Web Information Systems group at TU Delft. So nice to see you and welcome. So first of all, a brief recap about the theme of the speaker series before introducing today's talk. So in this speaker series, we focus on human-centered AI, which is a broad topic that studies, the design, development, but also the use and governance of AI systems for supporting human activities in a trustworthy manner. And this specific series of human-centered AI focuses on the knowledge and the language aspects, which are key concerns in making AI systems and humans understand each other and acting upon such a common understanding through interaction. Now, on these topics, we have invited a list of speakers whose work has made foundational contribution to these fields. This week, I'm thrilled to introduce our speaker, Heng Ji, professor at University of Illinois, Urbana-Champaign, and Amazon scholar. She's the director of Amazon Illinois Center on AI for Interactive Conversational Experience. Her research interests focus on natural language processing, especially on multimedia, multilingual information extraction, knowledge-based population, and knowledge-guided generation. She has received many recognitions and rewards, including the Young Scientist and a member of the Global Future Council on the Future of Computing by the World Economic Forum in 2016 and 2017, Women Leaders of the Conversational AI by Project Voice, AI's 10 to Watch Award by IEEE Intelligent Systems in 2013, and SF Career Award in 2009, and a bunch of other rewards. She has also received the Best Paper Awards from premier academic conferences such as ICDM, SDM, and Best Demo Award at ACL and NACO. She also actively served the research communities. She was secretary of NACO, the North American chapter of the Association of the Computational Linguistics, between 2020 and 2021, program committee co-chair of the NACO HLT 2018 and AACL 2022, and the coordinator of the NIST Text Analysis Conference Knowledge-Based Population Track since 2010. So today, Professor Heng Ji will introduce their work on situated report generation, and all participants feel free to ask questions, but please mute yourself during the presentation. You can leave your comments in the chat. And then after the presentation, you can unmute yourself for questions. Now, without further ado, let's welcome Professor Heng Ji. Thanks again, Heng, for being here. The floor is yours.
Thanks so much, Jie, for a nice introduction, and thanks for having me. So my presentation today is going to talk about a very brand new project. We just actually posted a paper to archive over the weekend. So it's called a SmartBook. And the goal here is to use AI to assist situation report generation. And the project is done by a bunch of my students, led by Revance Reddy, Steve Huang, Manling, Yifeng, Zoe Li, and Ziqi, and Vicky Jen. And this is really a effort that's kind of combining multiple projects that we have done over years. So first of all, what are situation reports? So it means that when we are facing an emergent event or some crisis, we really want to understand what's going on. So we want to get informed. So why this is challenging? Because usually for this kind of situation, we need to understand the common truth across multiple data sources in a timely fashion, because you may need to make a decision soon, or maybe you need to have some strategic development to prevent bad things from happening. So for example, in a COVID situation, we all very puzzled and confused, and we want to know whether we should bring a young kid for vaccine, and some guidance from some data sources will be very helpful. And for example, Ukraine crisis, some data agencies like the Data Friendly Space, they are writing this situation report once every month manually. So this will contain about hundreds of pages talking about what's going on there. So this kind of report will require us to have special dimensions. So first of all, it should include some really salient, important information. And then second, it should have some clear logical structure to organize information in a coherent way. And also it needs to be up to date. For example, the Ukraine crisis scenario changes very rapidly. So maybe every week or even every day, we need to update the report. And then finally, most important thing is we want to make sure all the content is truthful, is factually correct. So we need to ground all these claims and the conclusions back into the facts reported in the original source. And sometimes we may see some conflicting claims. Then in that case, we need to do cross-checking, do fact-checking, and also sometimes even need to correct the factual errors. So currently, this task is mainly done by human. In all kinds of government agencies, we have the senior expert analyst or junior analyst, and they also use some materials to train junior analysts on a daily basis. So the problem there is that, of course, it's very time consuming, and usually one analyst only understands one particular region or one certain time period about one particular topic. So it's very resource intensive and unscalable. And sometimes their report can be biased and incomplete just because there's so much information going on, they don't have time to read all the documents. And also, if the event is across the multiple countries in global wise, then it's very hard to keep up to date for those information coming from foreign languages and different data modalities like images and videos. So that's one limitation. And then the other limitation about the ceilings, when I say the first criteria is make sure the information is important enough for everyone to be aware of. So when the junior analysts receive a list of questions from senior analysts or commanders, they usually look at the questions that are important on a high level for long term. So sometimes these questions will become outdated, irrelevant very quickly. And also sometimes they are too high level just because they don't have time to read the news articles and or some other report and then come up with the new questions. So the questions tend to be very vague. And also, if we want to return answers from machine reading or use any AI tools, then these questions are often very complex. They are very hard to understand. So I give some examples in each bullet. So our goal is to generate a situation report automatically and then give this to the human analyst for editing. In this way, we can deliver a report in a much more timely fashion, and hopefully the report is more comprehensive and the information is organized in a more logical and coherent way. So how would this kind of smart book look like? This is an example. I will show some demo later if I have time, but it will look like this. So it will basically eject this kind of chapters from a time window. So currently for Ukraine crisis, we're updating the book once every 2 weeks. And under each chapter, we'll have the sections. So each section is basically a question. The question is generated automatically from all the input data. And then for each question, we'll eject claims. So claims are coming from multi-model, multilingual data sources. And each claim will come with a contact, and also you can go back to check the source. In the source, we also highlight the multimedia knowledge element as evidence. I will show that later. And then we will combine these claims and we will come up with the summary. And the summary, we try to check every piece of information using fact-checking and correct factual errors and put a citation back into the claims. So we also have this multi-model information as used as knowledge elements because sometimes the evidence is not enough just coming from text. So we collaborate with Columbia University on this. They extract knowledge elements from images and videos. So natural question, actually just before the talk, I was talking to Jie about, nowadays every paper needs to have a GPT-4 as a baseline. So when I was writing the slides, GPT-4 did not come out yet, so I just played with the ChatGPT. So you can see, usually they will just say, I don't have any information after 2021, or they will just make up something, it's usually very fluent, imperfect English, but very short and very generic, and sometimes very boring, because all of those kind of facts are just facts coming from the web. They don't have up-to-date information, and then they don't give you really any evidence. I mean, nowadays maybe the Bing search can give you a citation and you can go back to read the web pages, but there's no guarantee the information is truthful. And for certain questions like this, usually they return the answers coming from English text only. So I also tried more recent version, and also more specific questions, like, is Russian positioning forces for possible follow-on actions into Ukraine after initial invasion? So this kind of question is a very common and frequent question came from commanders or decision makers. So for ChatGPT, it just declined to answer the real-time information, and then it just gave us a very high-level recommendation that you probably can use this for any possible crisis scenario. And in contrast, I will show that how our SmartBook works. So it will give you a very concrete location, event and evidence, and the situation, some numbers, and also tell you some possible action items. For some other more like a factual information-based questions, like is, for example, what's the reporting size? Then usually this kind of large language model-based static generator will say, I don't have the current information. So for the same questions, our SmartBook will give the detailed evidence, and also for the size, it will aggregate information from multiple sources and report an estimated size. And this is just another example. What's the status of efforts to rescue these people? So these people were actually kidnapped about 2 years before the Ukraine crisis happened. So the ChatGPT will return some information, basically basic background information about these two people, like who they are, but it doesn't have any most up-to-date information on the current status. So in contrast, our SmartBook will tell us, US is still working on it, and they are having meetings, and they have some plans. So these are all the claims coming from multiple sources. And then this is another kind of why kind of question. So it's usually very hard for any regular question answering system to return answers, because it needs some reasoning and information aggregation and knowledge reasoning. So then in this case, ChatGPT returned a completely false answer. It says it's not a specific target for Russia just because information is out of date. So our SmartBook will say it is, and then explain all the reasons and some evidence coming from multiple sentences. And it's up to the analyst, of course, human analyst, to judge whether the reasons are strong enough for them to take any action, but at least we provide all the related evidence for this question. Yeah. So how can we do this automatically? Why this is beyond generation using large language model? So the first challenge is that we really need to keep the information up to date, right? So how can we discover so-called chapters or sections automatically? That's the first challenge. And then the second challenge is a lot of claims may come from a wide range of multilingual multimedia sources, and sometimes they're conflicting or complementary. So it's very important for us to aggregate the knowledge. And if they are conflicting, we need to do fact checking to see which one is truthful, or if nothing is truthful, then we need to search for background knowledge and try to fix the errors. So these are the challenges I want to go through one by one, and feel free to put your comments or questions in chat, and we can discuss later. So the SmartBook will look like a framework that aim to generate a comprehensive real-time situation report from different sources. And our goal is to not just write a summary, but also discover some critical strategic questions and then ground the content of the report back into trustworthy factual evidence. So it will start by some timeline data. So for example, in the CNN section about Ukraine crisis, they usually have the special section. They will, give you the updated news articles every day. So for this project, because we are just academic institution, we try to do a small effort. So we try to small effort in terms of the updating speed. So we try to aggregate information from every 2 weeks, and then we update the book every 2 weeks. So from that 2 weeks window, we'll then discover what we call as chapters. So chapters are the major events that are reported in that 2 weeks window. And then for each chapter, we'll use a document to headline generation system to generate the questions, the important questions for that 2 weeks window data. And then from those documents will extract claims, and I will explain how we do that. For each claim, we also have multi-model, multilingual knowledge evidence, knowledge elements as you can think of that as a knowledge graph to support each evidence to each claim. And then we also construct a claim network, try to see which claims are conflicting or supporting each other. And then we will use a controlled generation to generate the final summary. And then for each summary, you can notice that each piece has a citation. Each piece of claims or knowledge element does not have a citation. Citation means the corresponding claims. Then we'll remove that piece from the final summary so that we make sure everything is grounded back into the original claims. So to execute this kind of pipeline, we will need first to have a headline generator coming from the multiple documents from every 2 weeks window. And then after we generate chapters, we'll generate the questions also. And then usually the questions will have a lot of duplication. So we also need to remove the duplication, try to make sure that all the questions are the important ones. And then we will extract claims and knowledge elements and do the final controller generation. So you probably can see that although I said using GPT alone cannot solve this problem, but we do use GPT as our building block at each step, but try to do something better on top of it. So the first challenge is about how can we generate the chapters and the questions automatically. So as I said earlier, a lot of these questions from human analysts are static. Basically, they don't change over time. They don't get updated quickly enough. And also, it's very hard to parse some of these complex questions like this one. And sometimes it needs us to do multi-hop reasoning and aggregation. So the questions, can we generate this kind of questions automatically? So what we did is we first try to cluster the news articles from a certain time window. So for example, if we have 2 weeks news articles, we try to cluster them based on the topics and events. So this clustering is very simple. We just use some TF-IDF-based metrics to cluster the documents. And then for each cluster, we use a BART model to generate a headline controlled by the input documents in that particular cluster. So after we have that chapter name, then we use another controller generator to generate the questions grounded into the corresponding articles. So for example, we'll have, during different iteration, we'll have different question sets, and then we try to remove the duplicate ones and only focus on the questions coming from multiple iterations, multiple variants. But we make sure that all these questions are relevant to the input article. So for each timeline, we'll have some chapter names that will look like this. And each chapter name basically can also correspond to a bunch of questions and headlines. So to that extent, it's almost like a multi-document, some news summarization, but we try to only keep the important questions and the chapters. And then for the detailed content in that book chapter, will then generate based on more fine-grained claim detection and knowledge extraction. So first of all, how can we detect claims? We used a multi-step method, try to detect the claim, what we call claim frames, incrementally through direct questions. So first we will try to spot which sentence includes a potential claim. And then for each claim, we'll try to find the claimer and the claimer's affiliation and then the span for the claims. And under each claim, we also try to extract the topics and the object of that claim. So for each different scenario, we'll have different types of topics. So for example, these are the topics related to COVID. And then it's very important to find the knowledge elements that can be serve as supporting evidence for each claim. So here we use our multimodal, multilingual information ingestion system. This is actually my core expertise, and I have been doing this for many decades. But just want to highlight some new development in this area. So we recently extended the information ingestion from sentence level to document level. So the idea is basically human, when we do information ingestion, we don't scan through token by token and only look at each sentence alone. We look at the whole document, and we also usually have some sort of a template in mind. For example, here, if we already know there's a transaction event going on, then we will naturally have a template. We want to look for who is transitioning what product to whom with what value. And then we'll do information seeking, try to fill in these slots. So the idea is to put this input document together with a template as our condition, and then use generator to fill in the blanks. And we also make sure that we only generate the knowledge elements that appear in the source document, so there's no hallucination problem. And another interesting development we did along this line is we found that code language model usually is much better than natural language model for this purpose, because code usually they are cleaner and they have certain structures and certain features in program language, like for example, the class names or the inheritance from this kind of functions. So it's basically better generator for this task. So we can also naturally define the ontology into classes, and then we can just let the code generator to instantiate for each element type. Yeah, so just very briefly about how we generate the knowledge elements. So the advantage is because we can leverage things like the inheritance. So if you define one event, then when you have a new event, as long as they are related, then you don't need any training data, just inherit the class from that old type. And also because we are targeting at the heterogeneous sources, we of course need to find the information not only from natural language, but also from images and videos. I should say that the research this direction, like in this direction, kind of coming up with the multiple claims and knowledge elements in computer vision is a little bit behind NLP. So because they don't have the real world news articles and the event annotation or entity annotation. So it's very hard to just transfer the current like object detection model from the general domain into this kind of real world complex scenarios. So we decided to do cross-media transfer instead. So that means we will define the events in natural language. So we use this structured format to define each event, and then we'll use multimodal common semantic embedding representation to extract the corresponding structures. So you may ask that, maybe Clip is already able to do this, but a Clip does not have the alignment between image and the text on the structure level. So we basically extend the Clip into something we call as Clip event. So the alignment is based on the structure level. So we will look at the scene graph and the situations detected from the images and align that with the corresponding elements from text side. So that's about how we detect the claims. And of course, the most challenging problem is once we have the claims, we don't know which ones are truthful and which one deserve to appear in the report. So then we need to rely on fact-checking or fake news detection algorithms. But then when we look at the existing methods, most of them were applied on document level, which means we only know which document is true or fake, right? But to do our claim level or knowledge element level detection, we really need to look into much more fine-grained knowledge elements. So we defined a new task, which is try to look at every triple in the knowledge graph. So after we get the multi-model information from a news article, for example, here, the caption will say, the police is shooting at the protesters, but the image doesn't show that evidence. So then we will say, oh, maybe this triple in the caption is fake because it's inconsistent with what we can discover from images and body text. So we define this new misinformation detection task on the knowledge element level. So the way we do it is, of course, we try to aggregate information from all kinds of data modalities, images, videos, and the captions and the body text. And then we'll do cross-media co-reference resolution on event and object level. For example, the shooting in the caption, we need to know it's aligned with this bounding box here, showing a police was holding a gun. And then from this multimedia knowledge graph with evidence from the original source, we'll try to determine which triplet is consistent or inconsistent with other triplets. So one big challenge to train this kind of fine-grained misinformation detector is we don't have any training data, because usually human-written fake news will be removed immediately or maybe within a few days. So we need to have a scalable method to generate fake news detection, fake news automatically mimic how human will do it. So just a quick disclaimer here: we are not going to share this generator. This is just serving as automatic way to generate training data for our detector. So the traditional way to do this is just randomly replace some knowledge elements and then use that to control the generator to generate a fake document. But that kind of document is not really on the level of how human would manipulate information. So for example, if I simply manipulated the bicycle, if I replace this bicycle with a truck, then the truck doesn't appear in the image. Then, for human or machine learning model, it can easily detect this as fake information. So we don't want to manipulate the knowledge elements like that, which are already grounded in images and body text. So we only look at the knowledge elements that are not grounded in the image. For example, Zambia is not grounded in the image. We replace that with the most similar entity, Fiji. And then using this manipulated knowledge graph, then we generate an article describe that fake knowledge graph. So this kind of training data is very powerful if we want to detect the fake news generated from the same model, which means if we're detecting machine-generated fake news, then the accuracy can be like 92, 95%. So we thought, the problem is solved for detecting machine-generated fake news. However, if we apply the same model to detect human-generated fake news, which is what we need for SmartBook, the accuracy is only about 55 and 59%. So there are two major reasons. The first reason is that the automatic generated training data does not guarantee the information is fake enough. So to deal with this problem, we try to make sure that the generation is controlled by this method called self-critical sequence training, which means we want to make sure the sentence cannot be inferred from the original sentence, from the sentence that we messed out. So we used a natural language inference model to achieve that goal. So basically there are two goals here. One is to make sure the generated fake sentence is fake enough and it's also fluent enough. So fake enough, which means that it cannot be inferred from the original content and from the original sentence. And then the other big problem we noticed that the big difference between machine generation and the human generation for fake news is that the human is really good at using propaganda techniques. So according to the criteria or categories that are defined by Prisler, there are actually about 28 different categories humans usually use for propaganda generation. And most of them are almost impossible to automate. So we only try to do this for two categories. One is loaded language. So loaded language means some kind of language that can trigger strong emotions. So we basically first identify which position in a sentence can insert such a loaded language. And then we generate that loaded language automatically given the context. And then the other category we try to automate is appeal to authority. So propaganda usually look at, some authority said something and confirm something. So we start from some simple template and we use a generator to iteratively rewrite the sentence. So basically insert this yellow part into each claim to generate the fake claim that has appeal to authority. So after we do this, then the detection accuracy is much better. But of course, there's a lot of room to improve. We can see it's still much lower than the accuracy we achieved for detecting machine-generated fake news. Okay, and then after we detect the fake news, then another problem is sometimes the information comes from different languages, different sources. For example, Ukraine crisis. Maybe a lot of detailed information is reported in Ukrainian news, or maybe from some other foreign sources like Chinese or Finnish. So the current fact-checking or fake news detection methods usually are limited to English. So that's why we want to extend that to cross-lingual setting. So we developed a cross-lingual fact-checking framework for that purpose. And again, we don't have training data, so we need to generate training data automatically. So the way we do this, we consider this as a cross-lingual inverse close task. So it's basically similar to passage retrieval. So we basically take out a passage from the original article and then try to mask out that passage and use that as a training data. So basically from each passage written in a foreign language, we try to determine whether that can be inferred from another article written in another language. So you can think of this as a cross-lingual passage retrieval task, but the difference is that we want to make sure that passage can be inferred from the remaining content. So basically, usually when we do passage retrieval, we look at another article, but here we look at whether that passage can be inferred or generated from the remaining of the article. So by doing the cross-lingual fact-checking, we actually perform better than Google search. So when I say Google search means the data comes from Google snipped. If the language is unseen language, so that means it's a zero-shot setting. But if it's in domain, which means the language is already seen in the training data, then we did not outperform using the whole web as our data. And then we are also interested in how what kind of criteria should we apply when we choose the training data for our loaded source language. So we checked the performance according to the distance between the target language and the source language. So interestingly, not all the cross-lingual transfer works. So for example, if we remove Indonesian language, then you can see, for example, language like Bengali, usually the news articles talk a lot about similar topics, events as Indonesian news, then the performance was hurt a lot. But for some other languages which are far away from Indonesian, the performance actually goes up a little bit. So that means we really need to pay attention to the semantic level distance between two languages, not only about how close they are in the family tree, but also about the data is talking about similar events or topics. Yeah, so but overall, if we add more and more languages, usually the performance goes up quickly. So that means for fact-checking task, if we can get out of our comfort zone, do something beyond English, gather information from other loaded source languages, the performance always go up. So that means you can check your facts much more reliable way if you care about other languages. So here just another example showing why we are better than Google search for some cases. So the problem is because Google search usually give us I mean, Google search here means that we use a snippet returned by Google search, but we still use the same fact-checking framework. So it often have this uncertain decision. It only tells, mostly false or partly true, but our method usually can have a very assertive answer, say true or false. Okay, and then final challenge is that after we do the fact-checking, we still cannot determine what information to put into the report, because sometimes it's just all the information looks like false. So in that case, we really want to find the original correct information, because usually that kind of knowledge elements, it's there. If they are false across multiple sources, usually means they are very important information, because everyone wants to manipulate the information. So it's very important for us to go back to find the original evidence, the truth, and then put that truth into our report. So we propose a new task. It's called faithful factual error collection. Usually this is done again in a supervised fashion. You annotate a lot of data from Wikipedia and then you train a model. But this is not scalable for a news domain, because we just simply cannot afford annotation for all kinds of languages and data modalities. So we decided to do this in a zero-shot setting, but we do this step by step so that we can trace back our collections to see why we collected this claim in this way. So the idea is to get the input claim, and then we will decompose the claim into possible questions. Means what kind of questions are worth asking for this particular input claim. And then for each question, we'll then look at the reliable source using that as our evidence, and then generate new answers for these questions from those new evidence. And then we combine the original question and then the new answer together to generate a or what we call a claim sentence. And then the way we rank these new claims is based on whether this claim can be inferred from the evidence, and also some fluency metric like blue and rouge. So we want to make sure the claims is fluent, but also more importantly, it can be grounded back into the evidence. So we compared our methods with some supervised methods. So for example, T5-4 here is trained from human annotation. So you can see our methods can produce more faithful error collection results than this kind of fully supervised model. And all those output from our framework usually always faithful, because we can go back step by step by checking which piece is coming from which question and coming from which part of the evidence. So these are just some examples. In the first example, you can see our methods correct a mistake because of the domain adaptation. So the other advantage is this is zero-shot setting, so it can be applied to any general domain. So we actually train the model from news domain and apply to biomedical domain, for example, for the scientific domain. And we also, sometimes we can provide much better evidence to show why we do error collection this way. Usually T5 cannot provide that kind of evidence. So in the second example, you can see that. All right, so after we have this kind of error collection and other, trustworthy claims, then it's important to generate a summary, because usually the decision makers don't have time to check all these multiple claims from so many sources. So of course, this is just generally a controlled generation problem. So we use a query-focused abstract summarization framework. We gather all these claims, like 1, 2, 3, 4, 5, and then we try to generate a summary. So a major problem if we just use abstract summarization is it will have a lot of hallucinated information. So we basically try to control that process by checking every element in our generation, in our decoding, try to make sure that element, for example, a foreign power, comes from somewhere in the claim. So for example, number 5 says Sweden Security Service, so that from that we can infer there is a foreign power. So we can put a citation number 5 here. And if there's any piece coming from the generator decoder cannot be inferred from any of our claims, we simply not produce that as part of our summary. So basically, we first identify the most relevant claims for that particular target question, and then we'll add that kind of citation link back into each source for each fragment in the summary. By doing this, we guarantee that all the elements, at least in the summary, are truthful. And then if they don't believe if the experts don't believe that piece, they can always go back to the citation to check the content, right? Check the original claims. And sometimes they may also want to, just search for the web and edit our summary by adding more evidence that we'll see later in our evaluation. So to evaluate the quality of this book, we first look at whether the questions are strategically important, because we are not just writing a book for summarizing what's going on. We want to give some recommendations and some insights for the experts. So for that, then the questions need to be very insightful. They cannot just be some low-level facts-based questions. So we asked experts to evaluate whether any question, to what extent, is strategically important. So that's one criteria. And then the other criteria is we want to make sure whether that question is relevant, enough so that analyst is, the time they spend on gathering information for that question is worthy. So they also look into whether the question includes enough technical information. So you can see that from the results. So we basically ask 3 annotators to look at 125 randomly selected questions, and you can see about 82% of the questions have some sort of strategical value, and also about 93% of them include some sort of relevant technical information. So this is good news. And to give you some comparison about this Russian invasion to Ukraine scenario, we can see that these blue parts are usually show that information is technically important, and if it's technically important but it's not it's not very relevant, we will highlight that in red color. So you can see for most of these questions we have enough blue color highlighted relevant information. So we also did some quantitative evaluation by looking at our results compared to a web search plus large language model search engine. So we don't know what's going on in the Bing search, but we try to mimic, we guess, based on our guess how they worked. So basically search the whole web instead of searching our heterogeneous news source collection. So we use the Bing search, and then we use ChatGPT, taking that as control and generating answer. So this will be our baseline. And then we asked experts to evaluate in terms of coherence, relevance, and strategicness. You can see depends on the background data, we'll have different results, but overall our SmartBook quality is better than this kind of web search plus large language models engine, especially on the relevance and the strategicness. So that's also good news. And here just showing some comparison for one example question. You can see here the web search plus large language model hallucinated this information anti-Ukraine. So this anti-Ukraine was not groundable into the data. So this part is hallucinating information. And our results show more strategic question, relevant information to this question. So in the credit-focused summarization baseline, it does not recommend any like a high-level strategic information. It's usually just kind of repeat what's in the original documents. And then we deliver this to the expert analyst, a senior analyst in our transition partners, ask them to edit this each summary for each question. So we allow this person to basically insert any tokens if they find that the evidence is not good enough. They can also delete information if they find some information is not very trustworthy. So we found that the overlap between the machine-generated book and the final book edited by human, the blue and the blue score are surprisingly high. And also, they only deleted about 2% of our tokens, which means most of the information we presented in the original book was accurate. So of course, the edit distance is still quite high, which is about 34%, which means they still need to spend time to edit the book before they show this to their decision makers. But overall, I think this can speed up the process of writing a book for the situation. And this is just an example about what kind of editing they were doing. You can see that in most cases, they just add more tactical information in the blue color in order to elaborate some certain aspects. Sometimes they will add some interesting insight in the screen at the end of the summary. We also asked them to show us the errors they observed from our report, and then they try to give us different categories. So we can see in most cases, the orange part is about incomplete evidence. So they still find the summaries too short. So they need to go back to check our claims and they added more into the summary. So this could be solved maybe by just lower down our threshold about what claims to be included in the summary. We can just write a longer summary. Maybe that will be the solution. Maybe after we add more from other languages and genres, maybe this summary can be even more comprehensive. So just to conclude, we basically defined a new problem, which we believe is an important problem and also worth doing, especially for people in academia that we don't have enough computing resources, but we want to work on something that cannot be solved by this large language models alone, right? And we found that 82% of the questions we generated from the SmartBook, they are strategically important, and 93% of them are technically useful. For the quantitative results, we found that compared to a web search plus ChatGPT, at least we can have 90% more relevant and strategically important information included in our final book. And only 2% of the tokens seem to be inaccurate. They need to be deleted. And we also make our system and demos public available. Actually, now is maybe a good time for me to show demo really quick, if I have time. Jie, do I have time for demo?
Maybe very quickly
Okay.
to leave some time for the audience to ask questions. But you can also maybe post a link in the chat so that people who are interested can go and take a look. Oh, there is a link that I can see.
Yeah, I can. Yeah, so I can just. There are a lot, so I'm just going to.
Of course.
Some of these, so some of these are demos, and some of these links are just our source code and Dockers. Yeah. So basically, the SmartBook will look like this. We have the different chapters, and for each question, we'll have for example, this one is about nuclear power plant, and the summary will have the citation. Citation goes back to the claim. And you can also check the source if you don't believe the claim. And each claim, we can also go to this claim system demo. Basically, you can search the claimer affiliation, object location, topic, and so on. So for example, if I just pick a random, I don't know who is more interesting, but like there are some individuals and also some organizations talk about COVID-related topics. So, for example, I remember this person is some official. You can see this is a claim from this particular individual, and then you can go back to check the knowledge elements evidence. So here we did our multimodal, multilingual knowledge extraction, information extraction. So we can see the corresponding entities, events, and relations. And we also can show what other claims are equivalent and refuting or conflicting. And then we also have this demo, you can play with it in real time. So let me just clear this up. And for example, if I just copy any random sentence from today's news about Ukraine crisis. So, we are a poor academic institution, so I don't have enough computing resource to even to host my demo. So my demo is much slower than the system itself. So here I'm only showing a short sentence demo, but the system is much faster if you have enough computer resource to run it. Yeah, that's all. I happy to take any questions or comments. Yeah.
Thank you so much for introducing SmartBook. It's such a big project, and I can see how much effort you really put into this to make it work. Now the audience can unmute yourself to ask questions.
Hey, hi. I have a quick question. Thanks for the talk, first of all. In the second demo, you showed briefly that you display also like the, let's say, related claims, let's say for a certain piece of text. Is that something that you sort of generate in, let's say, your framework, or you use like, because I've seen a while ago, I'm not, let's say, 100% familiar with those. But for example, in the explainability, let's say, research area, they were applying this idea of influence functions that they could, let's say, sort of explain by example, like for a given model, tracing back to the original training examples and providing those as additional explanations. Is that how you retrieve those?
Just make sure I understand your question. Are you asking how we extract these claims from
No, I think it was the second demo.
Oh, you mean not these? You mean these?
Yeah, our equivalent claims. That's how.
Equivalent claims. Yeah. So we used some simple entailment-based method to do this. So we have 3 categories. So one is equivalent, the other one is supporting, and the other one is refuting. So you can think of this as a claim-claim relation detection. And the metrics we used were very simple. For the equivalent claims, we also look into the co-reference resolution. So because in our IE system, information judge system, we have a co-reference resolution. So we use that as a feature. So that's a separate component I forgot to mention in my talk, but yeah. So after we extract claims, then we construct that kind of claim network by detecting the relations among claims.
Okay. I see. Thank you.
Yeah. So for example, this one is about the origin of the virus, and this guy was talking about coming from bats. And you can see the supporting claims are about animals, and the refuting claim says it's from Wuhan, human, or something like that. Yeah.
Yes, cool. Thank you.
I also see a question by Chong Shen. Do the general questions in set following some logical order? Oh yeah. So first of all, the book is already ordered based on timeline, right? So every 2 weeks we'll have a new version, and then under each timeline, currently the order is based on importance. So it's not exactly like temporal order, but yeah. So we believe that in these 2 weeks, for example, this question is more important than this question. And also for this supporting element, like the one I just showed, for this, we didn't visualize this, but for these events we identified, for example, visit and invite, we also detect their temporal and causal relation. So theoretically we can visualize them into a timeline. We just didn't do that in visualization. I don't know whether that answers your question.
Yeah, it does answer my question. Thank you.
Yeah. Oh, but you are actually suggesting something cooler, which is the, between questions, whether we can, infer one from another. We didn't do that. I think that's a good idea. That's probably very important thing we can do to make sure these are also coherent. Like, for example, the commander 6 is related to the chief in Ukraine, something like that. Yeah.
Thank you.
Thank you.
Thanks. And maybe while the other audience is thinking, I also have a question. So SmartBook is a system with many components, right? So it's quite complex. So maybe based on your experience, which task do you see is most challenging? For example, so I've seen document level information extraction, which is already quite a challenging task, and then you also have summarization, right? So which one do you see is something that requires more future work, let's say?
Yeah, that's an excellent question. So my answer could be biased because the central thing I'm working on is information injection. So I don't think just traditional information injection, even from just English text, is so problem. So I showed 2 methods. One is use a code language model. The other one is use the document level natural language model to control generation to find those event arguments. So in any case, end-to-end information injection F-score is still lower than 75%. And I don't think that's a problem that can be easily solved just by increasing the size of large language models. We need more knowledge. We need a better design. We need to better leverage the features from program language if we want to use a code language model. And the other thing is, I talked about document level injection, but information injection across the whole corpus, right? And we don't have anything can do that. Like everyone just focus on sentence level, processing using sequence to sequence model. So ideally, we want to take the whole corpus as input and populate a knowledge base automatically. So that's one challenge. And the other one, also closest to my heart, is the fake news detection. So I feel like nowadays there's a hype about this area. Like people always say, oh, we can do better than human. But a lot of the results are reported based on detecting machine-generated fake news. So I showed that our best result is only about 69%, right? So there are like 30% of human-generated fake news are impossible to detect. The reason is because human are usually so much more intelligent than machine. They use propaganda. They look at very novel information because other human readers tend to believe the information if they don't know anything about that piece of information. So there are a lot of tricks they play and strategies they use in their fake news report cannot be automated by a machine yet. So I think that will be another important challenge. And then finally, I just want to kind of call the community to focus more on low resource setting, because to gather accurate information for this kind of emergent situation, you need to care about the local newspaper from a country that you usually don't care about. So the whole community is still, focusing on keep increasing English large language model, right? So we should have language models for every single language in the world. So that's my kind of thought.
Yeah, thanks so much for sharing this. It actually answers the questions that I was about to ask as well. So some people, what I know is that they are also trying the large language models to generate the synthetic data, right? Let's say for fake news detection, credibility check. So from what you just said, it's people now, we humans use all different kinds of strategies to generate fake news that are not yet possibly, that are not yet, which are not yet something that those large language models can possibly learn. That's very interesting. Actually, it seems that, do you think it's possible, let's say, to teach those large language models to do that? Of course, there's ethical concerns, but then people might start working on that, right? It's something that is hard to avoid, I would say. But yes. So what's
Yes.
your view?
Yeah. So first of all, the definition of fake news is quite vague, right? I mean, some information is not entirely misinformation or disinformation. They are just talking about the same events in a different narrative, different framing. For example, about Nancy Pelosi's visit to Taiwan, U.S. news will be talking about, it's a great visit, and Taiwan should be independent. But in news from China, we'll be talking about this military exercise, protect our border integrity, land integrity. So it's the same event. It's all about she's visiting Taiwan, but it's a completely different narrative and framing. So I think to teach machine how to write a story in a different framing strategy is important. Yeah, but I agree with you. We need to be very careful because easily it will learn, to spread propaganda or like misinformation. But I think when we say control, instead of just putting a prompt, like a topic or just one sentence, the control should come from many other aspects, maybe framing, intent, someone's stance, moral value, social norm. So on the positive side is we can then teach the language model to say things in a more appropriate way so that they won't trigger certain emotion or negative things from the certain population audience. Yeah.
Yeah, thanks. By the way, we are 3 minutes over the time limit. So if you need to go, please. So just for you to know. But then if there is one more question from the audience, maybe you can speak already and quickly. So I myself have another question, but maybe I'll keep it offline. That would be easier, I think.
It's okay. I have time. Yeah.
Okay, then I will simply ask. So this idea of leveraging a programming language as a way of doing document level information extraction, I think that's super cool, and it seems a method of combining neural networks with all these symbolic approach, right? Because now we can really define what are the interesting things to look for in the text. So I was just very amazed by how that was done.
Yeah.
So what is the? I want to learn a bit more about this. So did you ask some let's say humans to write what are there to be found through the programming languages?
So the only thing we need to do manually is to convert. For example, this is our ontology, right? Convert the ontology into class, but it can be very simple. Maybe just take a student 20 minutes to do this.
Oh,
so here is a definition of transportation event, and it will say transportation has these different arguments or participants. So basically, we define a function called transportation, and the inside we say artifact equals to something, and then the code generation will basically fill in the missing part.
I see. So what's required manually is basically the definition of the ontology, right?
Yes, exactly. Yeah. So other things, like for example, you can also put the more examples here in the comment in the doc stream. So you can think of this as in-content learning, right? So here you can put as many examples as you want. But I do have to say, because we are again using other people's code language model, we cannot easily change the upper limit of length. So here we cannot add more than 50 examples.
I see.
Yeah, but this doesn't need any manual work either. You just put in your examples here.
Is this something that GPT can also do? I'm sorry, I will constantly ask questions.
Yeah. So we compare. So in this paper, so it's also on archive. I can send you offline. But in this paper, we compared with using GPT alone, and the performance is better than using GPT. So there are many reasons. One is because this kind of task, structure prediction, really match the code programming language structure, right? Because programming language has all these structures, and we can also do inheritance. And then the other reason is because the data behind the code language model tends to be cleaner than natural language model, because they only use the programs that are rated higher than 4, I think, from GitHub. Does it make sense? So those are from good programs. Yeah. So that like from bad actors, the whole web, right? And then the other thing, I think it's interesting that it's not cannot be done by natural language model is the interpreter or compiler. So our ongoing work is we actually try to execute the code, and then from the if it cannot be executed, usually it will give the compiler will give us some feedback. Right, and then we can map that feedback back into the original token in the sentence, and then using attention, and then we can. So it's kind of getting some feedback automatically, and then we can use that for reinforcement learning. Yeah. And another cool thing is it's not limited to language. It can also be done for understanding the structures from images and videos. So actually my collaborator, Carl Von Jig, he didn't really publicize it, but he posted the ECCV submission, I think, to, or CVP, I don't remember, to archive. So now it's like viral on Twitter. So it's called Viper GPT. VIPR GPT. So it's about using code program language model to extract those kind of objects and structures from images. So I highly recommend that paper. It's very cool.
I see. Yeah, sounds very interesting. I'll definitely take a look. Yeah, thanks again, Heng, for sharing your deep insights from all this experience. Do we have one last question from the audience? If not, I think we can finish it here. So thanks again, Heng, for being here. It's a great pleasure to have you.
Thank you, and looking forward to meeting you in person one day.
Yeah, for sure. Likewise. And thanks everyone for joining the Academic Fringe Festival. Next week we will have thanks, and thanks everyone for joining TAP this week. We will see you next week again for the Matthias talk on system infrastructure for data-centric machine learning. So see you next week, and see you, Heng.